welcome to Cloud Concepts. In last video, I have explained about the shared disk architecture. Now, let's discuss on the shared nothing architecture. So you can see that shared nothing architecture here. So here, shared nothing architecture has distributed cluster nodes with their own CPU, memory, along with disk storage. It means like if you see here, this is the cluster nodes that we have. Maybe we can say is cluster node 1 and cluster node 2 and cluster node 3. So each cluster node we have its own CPU and its own memory. Similarly for cluster 2, CPU and memory for same. Similarly for cluster node 3, its own CPU and its own memory. See up to here, whatever the cluster nodes and CPU memory we have seen in previous video of shared disk storage, it is same. But if we see difference is here like disk storage. It means if we see here shared nothing architecture, we having a own disk storage for its own cluster. See, this is cluster node 1. Okay. For this node 1, what we have? CPU we have, memory we have, disk storage also we have. Similarly for cluster node 2. For node 2 also we have CPU, memory and disk storage. And cluster 3 also we have CPU, memory and disk storage. So here it's having its own cluster, CPU, memory and disk storage. Here there is no sharing between the cluster nodes. It means like if you see the previous which I has explained about the shared disk storage, if we see that we having, this is the shared disk architecture, we having here cluster nodes we have this one, 1, 2, 3. But here we have only one storage. It means disk storage. One disk storage, it is sharing with 3 nodes. But whatever we having in present shared nothing architecture, we don't have such shared disk. We have its own shared disk. So there is no dependence on all the clusters. They have independent CPU memory, disk storage. So, and in this architecture of shared nothing, so the data is in partitioned and stored across these compute nodes in their own disk storage. It means like data is partitioned and stored across these compute nodes. Means, so what we have here different storages like for this nodes. It means like the data is partitioned. It means like, for example, we the data related to employee and one of the company. For example, let's say TCS. So the employee is working TCS in Bangalore, Chennai, Hyderabad. So what this partition data partition means, whatever the data related to that employees working in Bangalore will be stored in one disk storage. So Bangalore data will be stored in one disk storage. Similarly, for Delhi data will be stored in one disk storage. Similarly, for Chennai data will be stored in one disk storage. So here this we call is this data as a partitioned. So Bangalore data will be in one storage, Delhi data will be one storage, and Chennai data will be in one storage. So okay, we up to here we know that data is partitioned. So and it has been stored across these compute nodes with these cluster nodes 1, 2, and 3. Okay, here. So what is that real-time example? For example, if any one of the user or any client has tried to fetch the data that of the employee that has been working in Bangalore, then these cluster nodes try to scan the data related to the uh, uh, Bangalore data and then gives the output. So let's say for example, the once the query has been processed, I mean written in the DB, he tried to scan the data where the Bangalore data is present in this disk storage. Then based on that, it will give the data to the user. So is it fast, right? Instead of scanning each table of storage, once the data is partitioned, means we kept all Bangalore data in one, all Hyderabad data in one storage, all Janagadh in one storage. Once the table of Bangalore data will get, it will give all the results in one shot, quick results. This is called data partitioned and it is stored in these computer nodes. And the process of this is called that, I mean, scanning of this data and giving the output of this from the partition data. This process is called the massive parallel processing. This is what shared nothing architecture when compared to the shared nothing architecture when compared to the shared disk architecture. Maybe you can refer to the shared disk architecture video. In my previous video, I had explained detailed explanation. Now maybe you can refer to this disk architecture and also maybe this sharing nothing architecture differences. So to know more about the shared disk architecture, you can refer to my previous video. Now let's have a real-time example to get more detailed of shared nothing architecture. Similarly, we have explained the same example of for the shared disk architecture. So here, for example, we have non-veg chef here, veg chef here, Chinese chef here. So non-veg chef will store his cooking items in one fridge, and chef will store his cooking veg items in one fridge. Chinese will place the same Chinese items in one fridge. So here, what we made here, so we made here some easy work. Instead of uh, both at a time, instead of going to one fridge taking the items, we made separated all the items, chicken items one side, vegetable items one side, sauce item one side, which is called, so chicken items one side, vegetable items one side, sauce items one side, which is called data partitioning. So we kept placing chicken items one bucket, vegetables in one bucket, sauce in bucket, okay, called data partitioning. For example, when one of a customer came and ordered the veg biryani, so then this veg chef will go directly to the vegetable fridge directly and get cooked, and then we can serve very fast to the customer. So even though we get some multiple orders, like at a time, non-veg at a time, veg at a time, and Chinese at a time, they will go to each related uh, stored items and they will get those items quickly, and then they will cook quickly and then can serve the customer. So this is called the data partitioning, storing the related data at one place. It's called data partitioning. And shared nothing is that, so whatever is having its own storage place, and everyone non-veg having its own storage, veg having its own storage, Chinese having one storage. There is no sharing between them. So what we have in data disk storage. So we have previously we have data disk storage, like these three are was to store in one fridge. So there was some delay in the output. But here now, currently there is no delay in the output. They can fastly serve the to the customer without any delay. This is called the shared nothing architecture. Hope you understood. Thank you.